Hello, ndikupasani moni nonse tsiku la lero pamene tikufuna kupanganso phunziro lathu la masamu. Tikupitiriza ndi topic ya circle geometry part 2. Today I'll take you through lesson 2. And you are with me, Cicero Juma. Today's date, 28 mwezi wa 4, 2024. Please be there. Let's be together. Yeah, so basically in circle geometry last week previous week munali Mr. Nyondo, where you discussed more about circle geometry part 2. Before this you went through circle geometry part 1, chord geometry, that is. So anapeleka background yabwino. I will advise sana ngati simunayionere ku video imene mupite mukayionere before kupitiriza lesson yathu ya lero. So in this lesson 2 we are going to cover 2 theorems. We are just building up pamene analekera Mr. Nyondo pa theorem 1, where you discussed about angle at the center and the angle at the circumference. Angle subtended at the circumference is or angle subtended at the center is twice the angle at the subtended at the circumference. So yeah, we'll go back and revisit that. So today we are going to add up on that formula. We'll look at the 2 formulas and we'll look at an example just to get an understanding of what we are talking about. So in this lesson, we'll first of all look at this formula where we are saying the angle in a semicircle is a right angle. The angle in a semicircle is a right angle. Choyamba tuzana kuti tikati right angle ndi chani. Right angle ndi any 90 degrees angle. So in this case they are saying the angle in a semicircle is a right angle. Tikati semicircle ndi chani. Semicircle is just more or less like a half of a circle. Same is just a half. So for us to have a half of a circle, we need to have a circumference. We need to have a center and a circumference. So the angle in that half part of the circumference, it could be this other side. It means this angle is 90 degrees. That angle is 90 degrees. It could be that very same side. That will come there. Okay, there should be at the circumference. Okay, yeah, something like that. Okay, so those angles we are saying are 90 degrees. So angle inayo semineni mu semicircle imeneyo imatipatsa 90 degrees. Okay, so in this one we consider looking at we are given this circle. We are given this circle with center O. Alright, and it has a diameter AB, and that diameter AB is subtending angle ACB. Okay, subtending angle ACB. Liwati subtending, you have used it a lot ku lesson loyamba. Chonde ngati simunamvetse, go back and watch that video kuti tisachedwe pa phunziro lathu lero. Yeah, so subtending angle ACB at the circumference, which means there is an angle here which has been subtended by AB. Okay? Yeah, so those are the points zimene tikuyenera tigwire before kupanga proceed. So ntchito yathu tufuna tionetse kuti indeed angle imene ili mu semicircle gives us 90 degrees. So we want to prove, we want to show kuti zona this theorem is true by doing that, by showing it kuti indeed angle in a semicircle is 90 degrees. So we are going to show each other on that one. So in this case we want to prove angle ACB is equal to 90 degrees. Okay? Yeah. So that's angle ACB is equal to 90 degrees. That's what we want to prove. Okay? So let's prove that. Okay? Now maybe we can just redraw our figure here. Okay, we have our figure, the simple one. And we have our center O. We have A, B, like that. And what's that other side? Okay, that's C. Okay, so first of all, we want to prove angle ACB to be equal to 90 degrees. Okay, so let's now show our proof. Okay, all right. So if you look at this, we have angle AOB. Okay, angle AOB, that one should be equal to 2 angle ACB. Okay, the reason is simple. Last week, the reason we did last week, and that reason is angle at the center, angle at the center, twice angle at the circumference. Okay, you did that theorem last week, and but we know that angle A, this angle AOB is equal to 180 degrees. AOB is an angle, it's a straight line, but it's an angle. Only that it's a straight line. But the angle of a straight line is equal to 180 degrees. So since we know that angle, that's an angle on, that's the reason, angle on a straight line. Alright, angle on a straight line. Alright, so AOB, yeah, so we can as well say 2 angle ACB the same as this angle AOB, which is 180 degrees. And if we want to find this one, we are going to divide both sides by 2. Alright, we are going to divide both sides by 2. So that and that will go. Here you remain with angle ACB will be equal to 180 divided by 2. That's 90 degrees. Okay, so that's 90 degrees. After dividing both sides by 2, that is. So that's angle. We are now confirming that's angle in a semicircle is a right angle, or is 90 degrees. So basically, for us to prove, to show that indeed angle in a semicircle, give us 90 degrees. That's how we proved. Okay, that's how we proved. Now let's go to the next theorem. And in this theorem, we are saying angles subtended by the same arc stroke chord Okay, we have this chord AB, or maybe before that, you try to draw it like that, this one. At that point, A and B. And in this one, sorry, yeah, so in this one, we have where that's M, and we also have that one, and that's P. Okay, so yeah, basically that's that. Ichi tanguikirapo, of course it has that center O. Alright, so we have this a circle with center O and APB, APB and AMB on the circumference. Okay, APB and AMB are angles on the circumference. Then, if you want to play around with this one, you need to connect these. You can try to connect that and that to have what we have here. So the theorem in this one, we are saying the angles subtended by the same arc stroke chord. This is an arc, this one is an arc. Right? You have done that with Mr. Nyondo. And or a chord, this one is a chord. Okay? Yeah, so in this case we have segment equal segment on. Yeah, right. And you make sure that those angles should be in the same segment. So in the same segment of a circle are equal. Theorem, that's theorem is saying angles subtended by the same arc stroke chord are equal. Or angles in the same segment of a circle are equal. We have two segments because we have this chord, see, cutting this circle into two halves. We have a major half where we have those angles, and we have a small half. So we are saying these angles, okay, the angles that are found in the same segment, that major segment, are supposed to be equal. And you make sure that those angles should be touching the circumference. Those angles amakala ofanana. Alright, so what we want to do now is to show that indeed that angle and that angle is ofanana. Alright. Yeah, so let us redraw it so that we should be having it from here. Okay. So we have a center O here, a center O there, PM. So yeah, so that's that. The same as that one. So now the thing is for us to indeed prove that this angle and that angle are equal. Okay? Because they are found in the same segment. Remember? Or yeah, they are found in the same segment. So we want to prove, we want to show that those angles are equal. So this is what we want to prove. To prove angle APB. Angle APB, this one, that angle is equal to, okay, is equal to angle AMB, that angle. So we want to prove that those angles are equal. But before we do that, we need to do a little construction. So construction, we are going to join OA. Let's join OA. Okay, and we join OB. Okay, we join OA and we join OB. Okay, by joining that, it means we have that angle at the center now. Because this is a radius, that is a radius. So we have those radii. So it means there is an angle that is being subtended at the center. Okay, so that's construction. We join OA and OB. Sorry. And OB. Okay. Yeah, so we join that, and then we need to, sorry. Yeah, so our proof now is to, we are now proving, we know that AOB, angle AOB, angle at the center, AOB, should be equal to, sorry, excuse me. Yeah, AOB should be equal to 2 angle APB. Sorry, angle A. P. Yeah, so we are saying that angle AOB should be equal to 2 times angle APB. Alright? The reason is that angle at center, okay, is twice angle at circumference. Okay, remember to put a reason pa china chiri chose mukupanga. It's very important. Alright? So we have shown that AOB, okay, is equal to APB, is equal to twice APB. And we also know that angle AOB is also equal to twice angle APB. Because the angle at the center is twice the angle at the circumference. The same, we're going to give the same reason as above. As above reason. Just give the same reason. Right? Since this angle is twice the angle at the center, that angle is twice the angle at the center, therefore 2 angle APB is equal to twice angle So right here it has to be M. So place the P up, it has to be M. Okay, AMB. Yeah. So it's AMB. Alright. So 12 akazopana, so you remain with angle AB. B will be equal to angle AMB. Alright, all these are equal to twice angle at the circumference. Yeah, so basically now we can literally conclude that indeed angles in the same segment are equal by using the first formula made by Mr. Nyondo. Angle at the center is twice the angle at the circumference. By using that, we have managed to also show that the angle in the same angles in the same segment are equal. Okay, as this theorem is stating, angles subtended by the same arc, okay, AB arc, right, and the chord, those angles are equal. How did we prove it? We had shown that this angle at the center is twice this angle. Okay? This angle is twice that angle. The same applies to that. Okay? Yeah, so that angle and that angle indeed are equal. And if you see, those angles are coming from the same chord. Okay? They're also coming, they are also in the same segment. Yeah, something like that. And as well, they are also subtended by the same arc. Yeah. So those angles amaineka kukhala ofanana. Right? As we have done here. Now let us look at examples. And let's look at this first example. I think we'll do one example. I think it's enough for the meantime. Yeah, so in this example, in this figure, RT, okay? That one is a diameter. It means it has a center somewhere. For it being a diameter, it has a center. They have told us it has a center O of circle. That's RT is the diameter of circle RSTV. Okay, that circle. Alright, but remember, in this case, if the angle RTV is equal to 65 degrees, this one should be, should be degrees. 65 degrees, as given there. RTV angle RT and in this case it has to be RTS. Okay, so angle RTS, that angle RTS is equal to 65 degrees as given that. So the question is to find angle TVS, is to find this angle. That's where the question is. So how do we find this angle? Now that's where we have to use my theorem ametapanga lero, and of course, yeah, my theorem also ametapanga lero. Remember, tunena kuti angle ine semseko equal to 90 degrees. We had that formula, we had this formula, where we were saying that this theorem, the angle in a same circle is right angle. Okay? But here, we are also given that this one is diameter of this circle. So it means it has bisected this circle into two equal halves. So it has that same circle and that same circle. It means here we are having this angle in that same circle, which means the whole of this angle, the whole of that angle will give us 90 degrees. Alright, because it's an angle in a same circle. So we are going to show all that After finding that, we know that angle 90 degrees, we know this angle 65 degrees, then definitely we have to know that angle. Okay, we have to know this angle. All right. When we know this angle, what it means is you find out that angle and this angle, all of them are being in the same segment. Okay, in the same segment. Or that's following this theorem. Okay, you have that up segment. Yeah. So we use these two formulas to solve that. So kumano chofunikira kwambiri ndikuonetsetsa kuti maformula tikuwagwiritsa ntchito bwanji. Ndikuyesa kulongosola motere kuti tithe kumva kuti kodi timagwiritsa ntchito motani. So let's now solve this problem. Okay, so let's solve it right here. Solution. Okay, so we know that angle RST, which is that angle RST will be equal to 90 degrees. The reason is simple. Angle in a semicircle. Okay, angle in a semicircle. That's the first formula. Okay, that we have covered today. Angle in a semicircle gives us 90 degrees. And we can as well find angle T, this angle, TRS. Okay, so in this angle, for us to find that angle, now we know that that angle is 90 degrees by that, and we also know that angle is 65 degrees. So you have a triangle RTS, you have that triangle. Okay, so in that triangle, we all know that angle in a triangle add up to 180 degrees. So you know two angles, definitely the third angle you should know. So in this case we'll say 180 minus, right, that angle which is 90 degrees plus 65 degrees. Yeah. Reason, angle sum in a triangle. Okay, angle sum in a triangle. So let's find that. So in our problem we have 180 minus, in bracket, 90 plus 65 bracket, okay, 25. How do I say that? 25. So it means this angle is 25 degrees. That one is 25 degrees. All right. Yeah. So, but we all know that angle TRS, this one, 25 here, should be equal to angle, TVS, okay, which is equal to 25 degrees. Reason, angles subtended, by same chord. You can say that all angles in the same segment. Okay. You choose one of those. Okay, it's either angles subtended by the same chord, that's the chord, and all angles in the same segment. Right. So basically, now we have found the value of TVS by using two theorems. The first theorem, angles in semicircle come 90 degrees. Theorem 1 Menel. 2, we have used angles in the same segment are equal. Yeah, so I think for today, let's stop there. Tunaona sabata mawa pametiza pitilizi lesson yatu ya circle geometry. Munali ndine once again Cicero Juma kupatsirani lesson number 2. Pitilizani kupanga share these lessons, invite those that might need them so that they may benefit as well. Thank you.